Now I've succeeded in getting the first column correct. I will go to the second column. I will start with the matrix, changing the elements of the second pivot to be positive 1. I guess we can multiply a negative 1 over 4 or dividing with negative 4. If I divide it with negative 4, it's gonna be a 0, then a 1, then negative 3, then positive 2. So we already divided with negative 4. This is positive 1, then it's negative 3, and positive 2. I will use this pivot to force the elements beneath it and above it to be equal to 0. معايا مستعد؟ I will multiply positive 2 and add 2 times 0 plus 0, it's gonna be 0. 2 plus negative 2 يا عم ب 0. 2 times negative 3, negative 6 plus 7 is gonna be 1. 2 times 2 is gonna be 4 plus negative 2, so it's gonna come up to 2. I will do it tell Mr. Ahmed. I will multiply negative 3 and add on the first row. Negative 3 times 0 plus 1, 1. Negative 3 plus 3, 0. Negative 3 times negative 3, 9. Plus negative 2, so it's gonna come up to 7. Negative 3 times 2, negative 6. Plus 5 is gonna be negative 1. And once more, we are hitting the second column. Very good. The last column. The pivot is correct. We are lucky. It's positive 1. So all I have to do simply is to start with the pivot of the last row, which is 0, 0, 1 and 2. I will use this one, Mr. Ziyad, to force negative 3 and 7 to be zeros. How to do it? I will multiply the last row by the opposite numbers, by the same numbers but with opposite signs, and we'll add them. So I will multiply positive 3 and add. Of course, these two zeros will help you out with those numbers. They will remain the same. So it's gonna be a 0 and 1. 3 plus negative 3 is gonna be 0. 3 times 2 is gonna be 6 plus 2, so it's gonna come up to 8. Similar manner, to force 7 to be a 0, multiplying a negative 7. Negative 7 plus 7 is 0. Negative 7 times 2 is negative 14. Plus negative 1, it's gonna be negative 15. 0 and 1. Stop. We had a reduced echelon form. At the same time, the rank of matrix A is equal to 2. The rank of the augmented matrix is also equal to 3. So we have the ranks are equal and they equal to the number of unknowns, x, y, and z. This is why we have a consistent independent solution for this system. It's called a unique solution. The unique solution is just only, this is the column of x1, x2, and negative 3. Is x1 equal to negative 15, x2 equal to positive 8, x3 misfated equal to 2. Those are the three numbers and only that will adjust the three equations at the same time. It's going to be impossible to find any other values that will satisfy this system of equation. It's done. Let's try once more to solve the second system. If we try to solve the second system, I will start once more from the beginning. The beginning is to get your matrix up and ready, which is 1, 2, 3, 3, 4, 6, negative 2, 3, 4.5. Then I will have 5, 8, then 12. I have nothing to do with it. I will have to change it, Mr. Amr, to the reduced echelon form. How to initiate the process to reach the reduced echelon form? Similar manner. I will start with writing the pivot of the first row, which is 1, 3, negative 2, and this is 5. Let's stay here to leave a space for the third system of equations. I will multiply negative 2 and add. Okay, Jana? Negative 2 plus 2, 0. Negative 2 times 3, negative 6 plus 4, negative 2. Negative 2 times negative 2, 4 plus 3 is going to be 7. Negative 2 times 5, negative 10 plus 8 is going to be negative 2. Same thing, so that I will need to force 3 to be 0. I will have to multiply 1 and negative 3 and add. Negative 3 plus 3, 0. Negative 9 plus 6 is negative 3. Negative 3 times negative 2, 6 plus 4.5 is coming to 10.5. Negative 3 times 5, negative 15 plus 12 is going to come up to negative 3. In a similar manner, I will have to change the second row. Let's go for the second row. The second row pivot will have to change to be positive 1. So I will have to multiply negative 1 over 2. Mr. Marwan, multiplying the negative 1 over 2 is going to be 0, 1, negative 3.5, I think. Then I will have positive 1. I think I'm correct. معايا Mr. Faisal? I will have to force this negative 3 to be 0. So I will multiply 3 and add in this row. Let's do it together. 3 times 0 plus 0, 0. 3 plus negative 3. 3 times negative 3.5, it's a negative 10.5. Plus 10.5, the result is 0. Multiplying in 3, positive 3 plus negative 3, it's going to be another 0. I'm not going to stop. I will continue. I will multiply in negative 3 and add on the first row. So it's going to be 1. Negative 3 plus 3, it's 0. Negative 3 times negative 3.5 is going to be 10.5. Plus negative 2 is going to come up to 8.5. Negative 3 times 1, negative 3 plus 5 is going to come up to 2. Stop. You can't do anything more. That's the reduced echelon form of this matrix. Let's talk ranks. Miss Fatin. بقالي كتير ما قلتش فاتن. Miss Fatin. The rank of matrix A is equal to 2. Okay? Okay. And it is equal to the rank of the augmented matrix because this row contains zeros in both the smaller and the bigger matrix. So they are equal to each other. Okay, let's compare them to the number of unknowns. Are they equal to the number of unknowns? No, they are less than the number of unknowns. So the ranks is less than the number of unknowns. In this case, I will have a consistent solution. Sorry, a consistent system with a dependent solution. Why do we call it a dependent solution? So this is x1, x2, x3. Expand as a polynomial. 1 times x1, 0 times x2, plus 8.5 times equal to, okay, same way like second row, it's gonna be x2, negative 3.5, x3 equal to, from these two equations, I can guess or find that x1 equal to 2 minus 8.5, the value of x3. And the x2 also will depend on x3, as x2 will equal to 1, but plus 3.5 x3. This is why it is called a dependent system of, or a dependent solution. Because x1 and x2 will depend on the choice of the values of x3. So once you put x3 with a number, let's say 0. So the results will be 2, 1, and 0. they will satisfy the system of equations. Let's change x3 to be positive 1. Then the numbers are going to change. We'll have value for x1, x2, and x3, and so on. How to mention it or how to put it as a dependent solution? Okay, as a dependent, we say x1 equal to 2 minus 8.5 c, and the x2 is equal to 1 plus 3.5 c, and the x3 is equal to c, which means the choice of x3 as an arbitrary constant will affect the results of both x1 and x2. By the idea, there is what's called the number of freedom, or the number of free variables. How many free variables exist in this system? It is the differentiating between the number of unknowns and the number of the ranks. We have 3 unknowns, but we have rank of 2. So we have 1 free variable, 1 degree of freedom. Where is the degree of freedom? This one. It's called a degree of freedom. In other situations, we may have 4 equations, but we will end up having the rank of 2. So the degree of freedom will be, and I will have to choose 2 arbitrary constants. Not now. Not now.
Not now.
Not now. Don't ask me now. Let's look at this system. Let's look at this system of equations. This system of equations is a 3 by 3. Once more, Ms. Fatima, once more, I need to solve it once more. So I will start with the augmented matrix. Ziyad, if
1,
أيوة
2,
قشطة 3, 4, and 6, and negative 2, 3, 4.5, and the results will be 5, 8, and 5. Okay. Start. The first row will be 1, 3, negative 2, then 5. I will multiply negative 2 and there. Negative 2 plus 2 equal to 0, negative 6 and 4, negative 2. 4 plus 3 is going to be 7, negative 10 plus 8, negative 2. Similar manner for multiplying the first and negative 3 and adding. Negative 3 plus 3 is 0, negative 9 plus 6, negative 3. Negative 3 times negative 2, 6. It's going to come up to 10.5. Negative 3 times 5, negative 15. Plus 5, so it's going to come up to negative 10. Similar manner to what we did previously, I will try to adjust the second row. In order to adjust the second row, this number should be positive 1. So I will divide on it, so it's going to be 0, 1. Okay, and dividing on negative 2, so it's going to come up to negative 3.5, then positive 1. Then I will try to get rid of the elements beneath it. So I will multiply 3 and add 3 times 0 plus 0, 0, 3 plus negative 3 is 0, 3 times negative 3.5, negative 2.5 plus 10.5, so it's going to be 0, 3 times 1 with 3, when negative 10, so it's going to come up to negative 7. I will stop. I'm not going to continue.
No solution.
In this case, I will have inconsistent, this is inconsistent system of equations, and we have no solution for this system. Let's talk ranks. The rank of the smaller matrix, the rank of A is equal to 2, and of course it doesn't equal to the rank of the augmented matrix, which is 3. So there is no solution for this system. Those are the 3 possible cases. We have the system of solutions or system of equations. There is a unique solution which developed from a consistent, independent system. From a consistent system of equations that will lead to independent solution. We have also a consistent system, but unfortunately it will give an infinite number of solutions, which means a dependent solution. Two of the variables will depend on the values of the other. And finally, we may have no solution, and it will happen when you have zeros in the younger matrix or on the smaller matrix, but not continuing this row in the upper matrix or in the bigger matrix, in the augmented matrix. There will be a mismatch in the ranks between the coefficient and the augmented matrix. اتفضل يا فندم.
وليه هنا وقفنا وهنا وقفناش؟ هنا وقفنا وهنا وقفناش؟
لأن هنا لما حصل ان ده كله بزيروز معناه ان السيستم still consistent and you can try to find the solution. This is why I've made a continuation giving the solution. Also, at the second step, I've completed the solution, multiplying in -3 and adding on the first row to become as much near to the reduced echelon form to have the solution. أنا هنا بكمل لأن ما عنديش عائق، لكن هنا أنا وقفت ما كملتش لسبب، لأن مفيش حل. اللي أنت كاتبه دلوقتي ده بيقول إن x1 times 0 plus x2 times 0 plus x3 times 0 بيساوي -7. يعني الليفت هاند سايد ب0 right hand side ب-7 which is impossible. فit doesn't mean or there is no meaning in continuing the solution. خلاص it's corrupted. You read me?
تمام.
واضحة؟
يلا.
أي أسئلة؟ تمام؟
بس
صوروا. أنا اللي أقول بس صور. خلاص هو متصور بس ده لازم تحله. يعني bottom line I want you to resolve it more than once. عايزك تحل ده أكتر. خلي بالك إن أنا لازم أضغط على نفسي وأنا بحلهم إني ما أزهقش. أنا عارف لو عملية إنك تحلهم ستيب باي ستيب فيها رخامة. بس صدقني أنت لو حليتهم كلهم جنب بعض زي ما أنا عملت دلوقتي تلاقي كل الريزلتس بقت موجودة في دماغك ونفسيتك اتحسنت وتعالجت. طبعا ده الفيرست سيستم اوف ايكويشن. مستر زياد بليز. ده الفيرست سيستم اوف ايكويشنز. Trying to solve them together, to put them together, one small coefficient, x1, x2, x3. That's the result. This is the augmented matrix. I will try to solve the augmented matrix as fast as possible. So I'm using 3-row operations. Mr. Ziad, please. Okay, once more, that's the augmented matrix. Multiplying the first row -3 and the -2 and adding them. I can do this as elementary matrices. بس خلي بالك يا فاكر ان elementary matrices each operation will be done in one elementary matrix. So actually, from here to there, I've multiplied the main matrix in 2 elementary matrices. Okay, same way, that's gonna be the third elementary matrix. This is gonna be the fourth and the fifth elementary matrices. Okay, then finally the 7th and the 8th. So actually these steps are done by multiplying the A matrix by 8. Can you imagine? By 8 elementary matrices. Okay, done. We already have a unique matrix. So the solution is unique and the system is consistent, independent. And you have them -15, 8, and 2. These are the results. This is the second system of equations. As you can see, I will continue, Mr. Ziad, because the ranks still the same. So this is the last step. Now I will try to expand them into equations, assuming x3 equal to c. So now I can have the solution of x1, x2, and x3, as you can see. This is the last system of equation. Solving it together, I will stop here. I'm not going to continue. Since the rank of the smaller matrix is then the rank of the bigger matrix. This is 2, the overall matrix is 3, so there is no solution for this system of equation. That's an example of a 3 by 4. 3 by 4. What's 3 by 4? It's an over-determinant system. Those equations in real life, they represent either goods or production variables or boundary or initial conditions in a certain problem. So here, I have the system over-determined, which means I have more equations than the variables. So here, if these 4 conditions are different, I will have no solution, okay? But maybe there is an equation in them, depends on the other. Let's start with this. That's the system that we have. Oh, I'm sorry also. That's a 4 equations in 4 unknowns. So that's a system 4 by 4. 4 by 4 is not going to make a huge difference. It's going to be exactly the same. But the unit matrix that I'm wishing to have is going to be 1, 0, 0, 0, 1, 0, and so on. Here are the steps in front of you. That's the last step, as you can see. That's a unique solution, of course. The rank is equal to 4. The overall is equal to 4. You have 4 variables. I can do the same for the inverse. I can get the inverse of this matrix and use the inverse to get the results. I can do that. This system of equations can be solved by the methods previously mentioned. Or I can get the coefficient matrix, get its inverse, that's its inverse, that's the inverse of the above matrix. After I have the inverse, I will multiply by the result. That's the inverse of my matrix. I simply will multiply it by 7, 4, and 6. Then I have the results, 0, 1, 1. That's also mainly all the methods that we saw, either Gauss or whatever, it plays in this game. Try to get the coefficient matrix, try to get the inverse, and then multiplying the next. We did that already in the augmented matrix. We did the multiplication, but within the processes that we are doing with the equivalence line. Okay? That's another system of equations. It would be nice for you to try it. It's different than the ones that we have. As you can see here, it's a 3 by 3 system. That's what I was telling you. That's an over-determined system. Those are how many equations? 4. In how many variables? 3. That's an under-determinant system, which has how many variables in how many equations? 3. So this system will never give you a unique solution. This system is between a no solution and independent and dependent solution, an infinite number of solutions. Okay. Okay. Here's the introduction about the basic concepts or how it is written or what we did go through. Now we can just screw through these slides. You will find them all, they are exactly the same. Look, screw, I'm sorry. This is the first equation. It's the definition of the coefficients, the variables, and the results. Okay, that's a system of equations. As you can see, that's the coefficients x1, x2, b1 up to bn. The system of equations, how can be built into inconsistent or consistent system of equations. The solutions, this is called a homogeneous system of equations. I have a question, please. That's a system of equations, but there is something remarkable in this system. Look at the results. All the results are equal to 0. This system, it is consistent system forever. It's consistent. But between two things, either a unique solution or independent solution, and it will be trivial ones yet. That x1 equal x2, that equal x, all of them are zeros. Or that's a solution. Or the other solution, you have dependent solution. So it will give 3 unknowns on behalf of the force or something like this. But it will never give you no solution, because the column of the results are all zeros. It's called the homogeneous system of solutions. He's trying to explain it for you. He's giving you a system 2 by 2, a homogeneous one. So if you remark the first equation and the second equation, they are identical. So the solution here will be dependent solution from a log of an I. x1 will equal to negative 2x2. So x1 values will depend on the value of x2. This is what explained over here, that alpha 1, which is stand for x1, in all times will be equal to negative 2 of alpha 2. This is the way it will be written down the road in order to be able to put it in a vector and the basis once we go to the vector spaces. These are the systems classification going through the augmented matrix, the bigger matrix, which contain the coefficient matrix and the results exactly the same. Okay, system of equation once more. This is the ranks, the stock ranks. This is the rank of A. Once it is did, then the rank of the augmented matrix. So you will have inconsistent system. So these two ranks are not equal to each other. شباب انتوا متابعيني؟ فاهمين بقول ايه؟ ده أول سلايد أنا بعته لك، أول سلايد هنا. السلايد فيه مربعات لازقة. فاكر السلايد اللي أنا كنت كاتبه لك consistent, inconsistent وهكذا؟ ما هو الرانك بتاع ماتريكس A doesn't equal to the rank of the augmented matrix. معنى ان الاثنين مش بيساووا بعض يعني consistent system. طيب لو الرانك بتاع الاي بيساوي الرانك بتاع الاوجمنتد ماتريكس يبقى السيستم بتاعك consistent. معنى انه consistent لو دول بيساوي النمبر of variables then the system is consistent and determinate, which means independent system of solutions. طيب لو هو delta n the system is consistent and interdeterminate, lower it means infinitely number of solutions or dependent solution. هيبدا يكلمك على degrees of freedom اللي هو difference between the number of variables والرانك زي البروبلم اللي احنا هنلاقيها مع بعض. اوكي طبعا ده الديستريبيوشن بالظبط قريب من اللي انا بديته لك في الاول بس الاولاني اسهل معايا يعني زي الامور اسهل ده inconsistent لو مش بيساووا بعض consistent لو بيساووا بعض determinant consistent system which means a unique solution. It means independent system of solutions. Indeterminate consistent, which means you have degrees of freedom. Then you go ahead with this then the number of variables. Those are some of the systems. This is a system of equations. As you can see, 3 equations in 4 unknowns. If you try to put them in a matrix of 4, this is the matrix. My question, Mr. Marwan, if that's gonna lead to a unique solution, it will never come to a unique solution. ليه؟ لأن the number of equations less than the number of variables. So the system in front of us, I will try to put it as much as possible into an echelon form. In this case, it is already on echelon form. The rank of the smaller matrix equals the rank of the longer or the bigger matrix. Both of them is equal to 3, but the number of variables is 4, so you will have the case of consistent indeterminate system or consistent dependent solution or infinite number of solutions. With how many degrees of freedom? The number of variables is 4 and the rank is 3, so you will have 1 free variable. Okay, all of this are given. The ranks are 3, number of variables are 4, so the degrees of freedom is equal to 1. In the exam you have, I can ask you plenty of questions about the system. I can give you the system as you can see, and I would ask you, the degrees of freedom of this system is 2. Is it correct or not? I'm not going to ask you is it correct or not, but I will give you a bunch of questions, and I will ask you to choose either the correct statement or the incorrect statement. You read what I'm saying? Okay, that's another system, solving a system S and getting the results. As you can see, hey, look, the first variable is x1, will depend on the value of x2 يا مروان. Next time مروان زياد اشتغلوا مع بعض. x1 will depend on the values of x2. x3 and the x4, they have definite values. But in all times, x1 will depend on the values of x2. Okay, that's the solution of the system of, as I told you, The system AX is equal to B once it has a unique solution. It's called a Cramer system. We will go through it in the next lecture. Let's stop over here because I feel that you start losing interest. So I will stop it here and we will continue next time. Thank you.
شباب